Hello students, welcome to the video tutorial of Informatics Practices for class 12th. Today we'll be discussing the fourth part of the chapter networking concepts for the computer network. Okay. Now in the previous video tutorials we have already discussed that what is meant by a topology, that is the way of connection of the network, that in which way we are going to connect a particular network, how we are creating the links among the network, and the different types of the topologies, that is the ring topology, the mesh topology, the bus topology, star topology. Okay, so all these things we have already discussed, and we have also discussed about the advantages and the several disadvantages of using a particular type of topology. Okay, so among them we have discussed that the best used network will be the fully connected network. Okay, among which all the networks are having the connection with the other several systems. Okay, suppose 50 systems are there, so all 50 systems are connected with one another. That is going to create a good network strength, so that will be considered as a fully connected network. Okay, so now let's today discuss about the factors which have to be considered for the topology selection, at which selection we should make for a particular network, that in which way we should organize the network. Okay, so that will be the basically a topology selection only. So now let's see what is there in the topology selection. So it is mentioned here that the factors that you must keep in mind for this are the cruciality of work. Now, first of all, you have to see that how crucial that particular work is. Okay, since the cruciality of the work is totally dependent upon the need of that situation or the need of the hour. For example, if you are talking about the military, so in military every second is crucial. Okay, so that is a highly crucial networking. Okay, so in that case we need a wholly connected topology, because we don't want to miss even a fraction of second of information. Okay, because at that situation it can be means a big failure if there is a small failure also. Okay, because every second is important in the military operations. So you can say that whenever we are going for a highly crucial work, okay, so we should go for the fully connected topology. Now the next thing is the cost. So keeping in mind the budget, you should decide about a topology. Obviously, you have to see which type of task you are considering in, and if the particular task is not too much important, if it can be prevailed after some, you can say, if it is taking too much time in the networking also, then also you are fine with the networking. Then you should go for the least expensive topologies. Okay, so you can say that fully connected is the most expensive way of creating a network. In the similar way, if you want a not too much expensive network, you should go for the bus topologies. Okay. Now the length of the cable needed is also important factor, because if you want the network to be small, okay, and precise, so you should use a small length cable. Okay, obviously when you are going to minimize the cable length, that means you are also going to minimize the cost of the networking. Okay, so it is mentioned that sometimes the length of the cable must be saved. The linear bus topology network uses shorter lengths of cable. Okay, so if you are going to use the linear bus topology, you are minimizing the cost of the cables. Okay, so the length of the cable is reduced, so obviously the cost of the cable is also going to reduce. Also the future growth is important. Suppose if you want a network to grow in a particular set of periods, okay, now you need such a type of network which can be easily grown, okay, without affecting the other nodes in that particular network. So it is better to go with the star topology in that situation. Okay, because the expansion of the network is far too easier in star topology as compared to other topologies. Okay, next is the communication media. So communication media, you can understand the way, the particular communication phase through which you are transferring that data. So here it is mentioned that sometimes difficult terrains like hilly areas do not allow use of regular cables. So in that situation you will need some specialized cables. Okay, so for that here it is told that you are using unshielded twisted pair. So according to that also you should go for the topology selection. So for these conditions where the hilly areas are there, you should go for the star topology. Okay. So you can see here that different instances are there in which we are choosing different types of topologies. Okay. So all of means whenever you are going for the networking, you should consider these factors, and among the choices of the factors, you should go for the particular topologies. Okay. Now let's see the next part of this chapter, that is the network devices. Okay, in this you can understand by the name itself, network devices means whatever the devices which are being used for the networking purpose. Okay, so it is mentioned that in the smooth functioning of a computer network, other than computers and wiring, many devices or specialized hardware play important roles. Okay, so in this section we are discussing about these network devices or the hardware. Okay, so the first thing which is the important part in the networking devices is the modem. Okay, so modem you are already knowing. Modem stands for the modulation demodulation. So basically, whenever you are talking about the modem, you are saying that modem is a computer peripheral, you know, that external device that allows you to connect and communicate with other computers via telephone lines. Okay, so why you need a particular modem? Because see, it is mentioned that modem is a device which allows the computer to send and receive data over telephone lines or cable connection. Now the standard telephone lines which are already means aligned in the particular city or in a particular place, it is not able to means handle the data which is a particular means digital data. Okay, so for that you need a device which can convert your digital data to analog data. Okay, or you can say you are modulating that data. Modulation and the demodulation have to be done in a particular device which can further distribute the signals to the telephone lines or the cable connection. So it is mentioned that because ordinary telephone lines cannot carry digital information, a modem changes the digital data from your computer into an analog data, and once it is converted into a particular analog data, a format that can be carried by telephone lines. Okay, so it is, but it is going to dedicate that telephone lines for this analog data transmission. So actually what you need a device which can convert your digital data to analog data and then transfer it to the standard telephone lines. And similarly, if any particular information is coming to your system that is in the form of analog data, so that particular device modem will now convert your analog data into a digital data, and that can be received by your computer systems. Okay, that is the functioning of this modem devices. Okay, now see, we are having two types of modems. Okay, first one is the internal modem and second is the external modem. So by the name itself you can understand that internal modems are the modems that are fixed within the computers, and the external modems are connected externally to a computer. Okay, so basically when you're talking about the modem, the internal modems, it is there as a port in your system. Okay, so you don't have to go for any external modem for this purpose, but obviously for internal modem you will be having the cable option only. Okay, you cannot connect it wirelessly. The internal modem have to be entered through a particular cable of the broadband or particular line connections. Okay, so that you are going to configure the internet in your system. Okay, so why we are using modems? Basically for accessing the internet. Okay, so if you are having a particular modem in your system, if it is an internal modem, you can go for the cable connection, and if you want the connection to be done through particular wireless situations, so you have to go for the external modem. Okay, now the next thing is the hub. What is a hub? A hub is a networking device having multiple ports that are used for the connecting multiple computers or segments of a LAN together. Now, there can be situations, suppose in your particular computer lab there are 30 systems and you want an internet connection among all those systems. Okay, so you cannot simply run the cables to each and every individual systems, because you are having only two ports in a particular LAN cable. Okay, so one will be attached to a particular system, then the second will be attached to the other system. So that same cable cannot be attached to the multiple systems, obviously, because you are having two ends of that particular LAN cable. So what you can do, you can use a hub. Okay, what a hub will actually do, it will give you an interface where you can connect one end of all the LAN cables, and the other ends will be into a particular each system. Okay, now through these hubs you can connect multiple systems. You're getting it? Suppose if you want to see the particular figure of this, I can show you the hub figure also. Actually it is a bridge, so no problem, we can go for the hub by the simple situation. Suppose if you are having multiple ports in a particular hub. Okay, and you have connected one system to a other hub. Okay, And suppose if you are having another system also, you are also connecting that single system to this hub only. So multiple systems are being connected to a particular hub, and now that hub is having the internet connection. So obviously all the LAN cables are going to distribute the same network internet to the multiple systems. Okay, so why we are basically using a hub? Hub is a networking device having multiple ports that are used for connecting multiple computers or segments of a LAN together. Okay, so it is also mentioned here. Basically, hubs are multi-slot concentrators into which a number of multi-port cards can be plugged to provide additional access as the network grows in sizes. Okay, so if you want to increase the network strength or the particular systems in the network, you have to add on multiple systems. So again, you can go on adding those systems with the single hub. Okay. Now the next thing is there are two types of hub. First is the active hub and the second is the passive hub. So active hub will also have a capacity or the strength to amplify the signals when it is transferring the data from one connected device to the other connected device. Okay, and what are the passive hubs? Because since the name indicates that passive means it is not having a particular strength of amplifying the signals. So the passive hubs will only allow the signals to pass from one computer to another without any change. So there will be no amplification in the signals. Okay, and the amplification of the signals in the active hubs are being done with the help of the repeaters. So we have already discussed what is the repeaters, that which is meant in a particular network for amplifying the signal. Okay, so let's move on to the next part, that is the switch. So what is a switch? A switch is a device that is used to segment networks into different subnetworks. Now, if you are having a particular connection or a particular LAN connections in your particular lab, you can say. So you can say that segmenting the network into smaller subnets prevents traffic overloading in the network. Okay, so if there is a large network, suppose, okay, and you want to divide it into some smaller LAN segments, so you will need a switch, okay, to join them. Okay, now a switch is responsible for filtering, that is transforming data in a specific way, and for forwarding packets. Packets means what? Data packets. Okay, so between LAN segments, switch can support any packet protocol. LANs that are segmented through switches are called switched LANs. Okay, so if you are using the LANs, so the LANs that are segmented through switches are called switched LANs. Now let's see how a switch functions. To insulate the transmission from other ports, the switch establishes a temporary connection between the source and the destination. Okay, so first of all, what it will do, it will create a temporary connection between the source and the destination, and once the transmission is done, then the termination of the connection is done. Okay, and then terminates the connection once the termination is done. A switch would be like a phone system with private lines in a place of the hub's party line. For instance, Mira Sain at the Moria Hotel calls Ibrahim's house in another room, and the operator or phone switch connects to two of them on dedicated line. This allows more conversation at any one time, thereby allowing more guests to communicate. Okay, in this way, multiple people can talk to each other without any problems. Okay, now see, whenever we are mentioning the switch, we can say that switch is an intelligent device. Okay, why intelligent device? Because it is able to recognize the particular, you can say that IP address. Okay, so there are two types of addresses, basically a physical address, which is known as the MAC address, and the second one is the IP address itself, or the logical address. Okay, so it is knowing that where we have to transmit the signals. Okay, so the switch is an actually a intelligent device. Okay, it is able to recognize the network efficiency and which type of network has sorry data has to be transferred to which part of the segment. So it is able to recognize that where is the need of the data, and it is transferring the data to that particular sub part of that lens. Okay, next thing is the repeater. A repeater is a device that amplifies a signal being transmitted on the network. It is used in long network lines which exceeds the maximum rated distance for a single run. Now see, here it is mentioned that a repeater is a network device that amplifies and restores signal for long distance transmission. Now, suppose if you are having the network in a very large area, okay, obviously the same information is traveling towards a large geographical area. So when you are talking about the repeater, a repeater is a network device that amplifies and restores signals for long distance transmission. So obviously you are mentioning that if the network capacity of that particular network is in a wide, large geographical area. So what you will be needing that the signal has to be transmitted at the same strength. Okay, there is loss of the data. Okay, so whenever you are talking about the repeater, it is going to improve the strength of the particular network by keep on repeating that signal and amplifying that signal to reach to the final destination. Okay, and next thing is the bridge. So by the name itself you can understand that it is bridging something. Okay, a bridge is a device that lets you link two networks together. So bridges are smart enough to know that which computers are on which side of the bridge, so they only allow those messages that need to get to the other side to cross the bridge. Okay, so obviously when you are having a bridge, then it has to understand that it has to allow only two types of signals to enter to the other part of the bridge. Okay, so it is basically a connectivity, but that is a smart connectivity again. Okay, so whenever you are transferring the information from one part of the bridge to the other part of the bridge, so only dedicated things which have to reach to the particular side of the bridge is only allowed, and the things which are not allowed will not be permitted to enter the second part. Okay, or the other connected part through the bridge. Okay, so bridges can handle network that follows some same protocol. Okay, obviously if the data which is entering to the bridge is following some protocol, then it has to follow the same protocol when it is entering to the second part of the bridge. Okay, so this is the bridging between two networks. Okay, now here you can see the figure also that how bridge works. Suppose there is a particular segment of LANs. Okay, so this LAN A is connecting computer 1, computer 2, computer 3 and computer 4, and similarly LAN B is there which is connecting computer 5, 6 and 7. So these are basically two types of segments of the networks. Okay, so there is a bridge between them, and there is two ports for them, port 1 and port 2. So suppose LAN B is sending some signals to this part, so this bridge will only permit them to go to this system only if they are following the same protocols. Okay, so if they are dedicated to go from here to here, then only the bridge will allow it, otherwise it will be returned back to this client. Okay, so the signal cannot be transferred until and unless the bridge permits them to transfer from here to this part. Okay, so here it is differing it from the normal hubs, where the hubs were used, there you are having again multiple connections of the lines, so they were able to transfer the information without any permission. There was a sharing of the resources without any permission. But here when we are using the bridge, that means it is having the particular set of rules which have to be followed from the one part of the bridge to the other part of the bridge. Okay, now let's move further and see what are the next devices. Here this is the router. So router, you are already understanding that whenever we are using a particular internet connection or a different types of network which is outside from a LAN connection, so you need a router device to connect that outer networking to our internal network. Okay, so you can say here that a device that works like a bridge but can handle different protocols is known as a router. For example, a router can link Ethernet to a mainframe. The router is responsible for forwarding data from one network to the different network. Now see, bridge was doing the same thing and router is also doing the same thing, but there is a slight difference between them. Bridge is going for the physical address, okay, and router is going for the logical address. Okay, here you can see that a router differs from a bridge in a way that former uses logical address and the latter uses the physical address. So a router is a network device that forwards data from one network to another. A router works like a bridge but can handle different protocols. In bridge, you have understood that it was also connecting two segments of the LAN, and only few segments were allowed to reach there, but they have to be on the same protocol. Okay, they have to be followed with the same protocol. But when you are talking about the router, they can handle different protocols as well. Okay, so even if the network is from the outside, it is based on the other protocol, and here the inside network is based on the other protocol, and both of them are under different protocols. Still the router is having the capability or the management functionality to manage these two networks and join them while handling the different types of protocols. Okay, so only the difference between them is that the router differs a bridge in a way that former, that means the bridge, sorry, the router uses the logical address and the latter uses the physical address. Okay, the physical address is also known as the MAC address. Okay, now the last thing is the gateway. Now in the name itself you can say gateway, that means it has to be a particular entrance of networks. Okay, so here you are saying that a gateway is a device. So basically, there is a difference between the gateway and the routers. We were talking about the routers earlier, so there was a bit of slight confusion there between the gateway and the routers. Let me discuss it again. See, when we were talking about the routers, if the destination is unknown to the router, so if the destination is unknown to a router, it sends the traffic bound to unknown destinations to another router using logical addresses, which knows the destination. Okay. So destination means what? If you are sending the particular information from a particular source, then it has to reach finally to someone. Okay, so that is the destination. So if the destination is unknown to a router, it sends the traffic to another router which knows the destination. Okay. So if the particular router is not able to understand that which address has to this data has to be transferred to, so it will send that data to the particular second router, okay, which is knowing the actual destination of that so what basically routers are having a roadmap, okay, which is known as the routing table. So routers can help ensure that packets are traveling the most efficient path to their destinations. Okay, now already we have discussed about the gateway. So gateway is a networking device that connects dissimilar networks. So the things which I have discussed in this particular router, everything was similar. Only one thing was there, that I told you that the external network can be connected to the internal network. So that is done with the help of this gateway. Okay. So a gateway is a network device that connects dissimilar network. That is the outer network, the external network is in a different network. Okay, in a different topology way it is connected. Okay, and when you're talking about the inside network, that is a different network. So what a gateway is doing, it is connecting two dissimilar networks. Okay, and it establishes an intelligent connection between a local network and a external network with completely different structures or the topology. Okay, so in enterprises, the gateway is the computer that routes the traffic from a workstation to the outside network that is serving the web pages. In homes, the gateway is the ISP that connects the user to the internet. So when we are talking about the local connection, so here the ISP, that is the internet service provider, is acting as a gateway which is providing you the external network, that is the internet network, to your local network. Okay, so in enterprises, the gateway node often acts as a proxy server, a machine that is not actually a server but appears as a server, and a firewall. Firewall, you know, only it is used for the security purpose. So what you are talking is basically that in enterprises, the gateway node often acts as a proxy server. Okay, so the particular node which is acting as a gateway is actually a proxy server, and there is also a firewall. Okay, and what is a firewall? Here in the particular network of the enterprise, a system designed to prevent unauthorized access to or from a private network. You are knowing that in an enterprise or in an organization, we are barring certain set of web pages. Okay, that is done with the help of this firewall. Okay, so to prevent that data secure means the security of the particular enterprises, we need a firewall system. So whenever we are having this type of problems in the enterprises, we can use a particular proxy server, which is actually the gateway. Okay, the gateway is also associated with both a router which use headers and forwarding tables to determine where packets are sent. Okay, so obviously through this gateway, you are able to understand that which is the particular header and what is the particular data which has to be forwarded. Okay, so it is mentioned here that gateway is also associated with both a router which uses headers and the forwarding tables to determine where packets are sent. Okay, so you are having both the information, that is the header, that what is actually the data and where it has to be sent. That information is also in that forwarding table. Okay, and a switch which provides the actual path for the packet in and out of the gateway. So it is actually a summary of all the networking. That gateway is also associated with both a router. Okay, so it is actually connected with the routers also, which uses headers and forwarding tables to determine where packets are sent. So this router will send the data to the particular different nodes, okay, because it is knowing the header, it is knowing the address where this information has to be delivered, and then it has to go through a switch which provides the actual path for the packets in and out of the gateway. Okay, so this is the procedure for all the networking concepts. Okay, so these were the different devices which can be used inside the network. Okay, that is the end of the chapter, students. I hope it was clear to you. If there is a certain bit of confusions when we will be revising in our offline classes, okay, so hopefully we will be able to manage those confusions, okay, to sort out those problems. Till then, students, take care. We will meet in the next video lecture with the new chapter. Okay, thank you, students.